All right, let's get started. So in this session, we're going to have a look at, we're going to build upon the stuff that we built in the last session, which is our banking application. And this time, we're going to look at Sagas and how they fit in the architecture. So what we're going to do is we're going to implement the money transfer using a Saga, and even though it's a rather simple application, and the Saga is not really a good, extremely good fit for this. We're just going to use it to showcase the example and see what Sagas can actually do and how they work. Of course, we're good developer citizens, so we start off by defining a test case. Then we're going to implement the Saga itself and make sure our tests pass. And finally, we'll have a look at how to set up the runtime components using the new configuration API of Axon 3, both using Spring Boot and plain Java approach. So let's go to the code. First of all, we're going to have a brief look at some of the changes that were made based on the last webinar. There's a new class here, money transfer, which is an aggregate, very similar to the account that we've created last time. This is the place where a money transfer request comes in. So it takes a look at the request for a money transfer, and it will apply events, and then we can complete or cancel the money transfer depending on whether we've managed to transfer the money or not. So there's actually no actual transfer going on here. This is just a request which has been placed and marked as completed. Then we have the account, which we've created last time, so that's all the same. And then we have the new the transfer API, where we have the complete money transfer command. We can cancel a money transfer, and then of course there's the events that go with it. So what we need to do now is create a Saga, and we call that the money transfer Saga. And of course we are starting with a test first approach, so we just need the class and that's it. Now we're going to create a test class. Let IntelliJ do the typing for me. And now we need to define a fixture, and just like the fixtures for aggregates, there's also a fixture for Sagas. And that's the annotated Saga test fixture. And we specify the class that we want to test, which is our money transfer Saga. And we create a field for this so we can use it in our tests. And now we can create our first test case. So the fixture will set up everything that's needed to run our Saga in a test environment. So there's not much configuration that we need to do as long as we stick to defaults in this test. So now we want to test the request, test a money transfer request. All right, so we say fixture given. There's no prior activity because we're testing a case where nothing relevant happened yet. Probably some accounts have been created in the past, but for the Saga it's not really important that these events are published. So we say when publish a money transfer requested, a new, and well, we specify transfer ID. We call that TF1 from source account 1 to account 2, and we transfer 100 of our currency, and then we expect. So we expect this money transfer to start a Saga, a new Saga. So we expect one Saga to be active at this point. You'll have to believe me, but when you start up a fixture, there's no Sagas at all. So if you start one, there will be one Saga. Then we expect to dispatch a command, right? So we want to expect a dispatch command equal to, we want to, when a request comes in, we want to take the money off the source account, and then when that succeeds, we want to put the money in the target account. So we want, as a result of the money transfer requested, we expect the command to be dispatched that will withdraw the amount from the source account. So we have account 1, and we expect 100 the currency. There's make throw an exception. So now we can run this test, and I'd be surprised if it passes. And of course it doesn't. It's failing because we're passing these events, but there's no Saga being triggered. That makes absolute sense, because if we look at our Saga, it doesn't really react to anything. So unlike Axon 2, we don't need to extend any classes. If we say to Axon, this is a Saga, it will do whatever it does to make it a Saga, but our class doesn't respond to anything. So we need to create an event handler. And in Sagas, that's slightly different than in regular event handlers. We have to use the Saga event handler annotation. I'll show you why in just a second. So we want to respond to an event, which is our money transfer requested event. And based on that event, we want to do something. We want to send out a command. So we need a command gateway. That's the easiest way to send out commands. And we want this to be injected from by the framework. So in this case, the Axon test fixture. If you're using Spring, Spring would do the injection for you. So we have to annotate it with @inject, and then we need to make it transient, because we do not want this field to be part of any serialized form of this Saga. So when we store the Saga, this infrastructure component will not be part of the data we store. And now we can send a command. We can send a new withdraw money command. And we need the account ID. We can get that from the event, which is a source account, and we get the amount from there as well. Now we still need to do two things, because we haven't said, we haven't told Axon that we need to start a new Saga instance when the money transfer comes in. And we do that by annotating the method with start Saga. So this tells Axon, when a money transfer request comes in, I want to create a new instance of this Saga which will handle that specific transaction. And I'm saying that specific transaction, but we're not pointing to any transaction yet, and that's what we need to do right here. So we need to specify an association property, and that is the property in the event that connects this Saga instance to a specific concept in our domain model. So in this case, we want to have the transfer ID. We want to connect this Saga instance to a specific transfer. So every time something happens to the transfer, this Saga is notified. If it happens to another transfer, then another instance is notified. And because we have specified start Saga here, it will create a new Saga instance, and that Saga instance will be associated with transfer ID as the key of the association, and the actual value of the transfer ID in the event is the value. And that combination is how we find Saga instances. All right, so test passes. Now for part 2, we we need to test the fact that the money is withdrawn. Sorry, the money is deposited when withdrawn from the previous account, from the source account. So we want to test deposit money after withdrawal. So given we have a money transfer requested, so that happened in the past, that will trigger the new Saga instance to do something. When a money withdrawn event from account 100, and we don't really care what the balance is. That's we expect dispatch command of new deposit money command to account 2 of 100. Now, you might think this looks okay. Well, actually, it doesn't, because what we do not have here is, well, somebody withdraws money from his account, but who says that the withdrawal is anyway related to the money transfer that we have sent? We can see the same if we send out the Saga. There's absolutely nothing in this command or event that we can connect this Saga to. We could connect the Saga to the account and then see if there's a deduction of money which happens to be exactly the same amount as the transfer, but who tells us he's not at the ATM at the same time withdrawing money while doing a money transfer? So we need to somehow be able to correlate those. So we need to change our API a little bit, and in our withdrawn event and command, we need to be able to specify some form of correlation. And we don't want to make it too easy, so we're not going to call it a transfer ID, because that wouldn't make sense if you withdraw money at an ATM. So we're going to call it transaction ID. So an ATM, maybe the transaction ID will capture the identifier of the ATM and certain things that we can correlate that. And of course, the deposit money command as well, and then the money withdrawn and the money deposited events need that data as well. Of course, I'm going to have some compile issues that I need to fix. So this is our application. Let's call everything transaction 1. This is the easy part. And now here, of course, we can't put a hard-coded transaction 1. We need to get the transaction ID from the command. Get transaction ID as well. So the aggregate itself, the account itself, is not really interested in the transaction ID at all. It doesn't do anything with it, so we don't need to change our events. It's not part of the state of the account, although it is conceptually part of the account, so it's visible in the APIs. Yes, now we have our start Saga here. So we need to specify some sort of transaction ID here, which what we can do is we can pass our transfer ID here. That should work. So let's compile. And of course we have some old test cases. Oops. Just get everything compiling. Nice typo, test deposit. All right, everything compiles. So let's see if everything runs. No. Wrong command. So our yeah, I was copy pasting a bit too fast. So we're passing in our transfer ID as transaction ID. So obviously I need to do the same in my test classes. So I have to pass the ID that we use for the transfer. We expect that to be passed in as the transaction ID. All right, so there's no command dispatched in this test case. And I guess that makes absolute sense because we're not responding to any events yet. So we have our money withdrawn event. And based on that event, we're going to send a deposit money command. And we're going to pass that to the destination account. But the withdrawn event doesn't know the destination account. So our Saga is going to have to store some state. And that's exactly what Sagas are for. They allow you, since they track a single transaction, you can store any state that you need during that transaction. So from our money transfer requested event, we can fetch the target account. And we can say it's the target account. And we create a field for that. We don't make this transient because we want to be able to store this, the data on this in this field. Let me switch off inspections. We don't want to generate any Javadoc yet. So let's, we now have the account, so we want to go to the target account. The transaction ID, well, that's the same. We could get it from the event. And then the amount is something we can get from the event as well. So we just assume that the money that is withdrawn is actually the same amount as the money that was being transferred. Let's just assume that assumption holds true. Now, we have another thing to do here. We need to specify the association property, but if you remember, the property is a getter on the event, and the getter we have here is called transaction ID. So we need to specify that here. But this Saga instance is not associated with the term transaction ID. It is associated here with the term transfer ID, although this transaction ID holds the transfer ID that we're associated with. And to override that behavior, so the fact that the property has a different name than the name of the association we use, we can specify the key name. And the key name is the name of the association. So now we get the instance of the Saga that is invoked with this command is are the instances that are that have an association with key transfer ID, and value is whatever the get transaction ID from this this event returns. Now we run the tests again, and everything passes. So let's quickly finish this. So when our deposit is successful, money deposited event, then we want to send a command to the money transfer to complete the money transfer, so that whatever system was requesting the money transfer is actually notified of the fact that everything was successful. And we need a transfer ID here. We can get that from the transaction ID, and we need to do the same stuff here. Now when the money transfer is completed, we need to to stop the life cycle of this Saga. Otherwise, we have a Saga instance that lingers on forever, because there's nothing ever going to happen on that transfer anymore. So what we can do is money transfer completed. And there's two ways of ending a Saga. We can do end Saga annotation. If the end is conditional, we can also call Saga lifecycle.end. It's a static method. Axon will know from which Saga instance that method was called, so it will end the correct instance, now like static imports. So this is actually the same. So it doesn't matter whether you use the annotation or the method, except when you have a conditional end, which we do not have in our case. If the money transfer is completed, we can end the Saga. Of course, we didn't have a test for this, so let's quickly create a test. Test transfer complete after deposit. Oops. So now in our previous, the event that we did as a when in the previous test is now a given. Oh, the API doesn't. So when publishing a new money deposited event on account 2 for our transaction transfer 1, and the balance isn't important, then we expect a dispatch command of complete money transfer command for transfer 1. That passes, and then the last test case, because we want to be able to test that the Saga stops. Saga ends after transaction completed. And now again our when becomes a given. We have a new when publishing a new money transfer completed event of TF1. Then we don't expect any dispatch commands. We can explicitly mention that if we want. But we also expect no active Sagas anymore. So we expected that the Saga that we have created in the process is actually well, gone by now. And everything passes. So this is our little Saga process. Now, of course, the interesting case is when we overdraw the source account. That's a scenario that we have implemented in the previous webinar. So let's have a quick look at what happens there. So when publishing a money transfer requested, we expect withdraw money. What I'm going to do is I'm going to do this in the plain configuration. So let's go to the application first and see how we configure this. So we have our configuration here. Let's get the scenario running at in a proper runtime environment. So what we want to do is we want to create 2 accounts, and then we want to create a money transfer. So we want to send a transfer request money transfer command to transfer under the identifier, whoops, TF1 we're going to transfer money from account 1234 to account 4321, and we're going to transfer 100 of our currency. So when I run this, it will dispatch the commands, but probably there's no handler for that command, so it's complaining that my request money transfer command isn't going anywhere. That's because the money transfer aggregate is not registered, but our Saga is not registered either. So we need to configure a register a module, which is a Saga configuration. Now there's two types of configuration. Sagas can be subscribing and can be tracking. Tracking means that the Saga manager will run in its own thread and track a stream of events. The subscribing one allows us to execute the Sagas in the same thread that also publishes events, which makes it somewhat easier for a main application like this to run, because at least we can be sure everything runs in the same thread, so we don't have any concurrency issues. The Saga type is the money transfer Saga, and that's all we need to configure. Then we can see what happens. Now we can see our commands, but we don't see the other commands. We expect to see that the Saga sends commands, and the reason we don't see that is because we are just sending it, but we don't have any callback. So I want to put the logging in here as well, so at least we can see that the commands are being sent. So here's our list of commands. We can see we create an account, and then we see withdraw money, and that's probably something you wouldn't expect. We see that the complete money transfer command is here, and then the request is behind it. That may look very weird, but it actually makes a lot of sense because everything runs in the same thread. So the command gateway, as a result of this event, we send a command. So that command will finish before the command finishes that trigger that event, because everything is the same thread. So everything is executed in the right order, but the callbacks are invoked in a different order. And just in case you don't believe me, we can do a logging event handler, and we can have an event, create an event handler that listens to all events that we have, and we do a system out event received. Let's just do event.toString. We'll be able to recognize the type of object. So we need to register that as a module as well, which is an event handling configuration. And we want to register an event handler, new logging, it's a lambda expression, new logging event handler. So we're creating an event handling configuration. The assigning handler by package is how Axon will divide the event handler components into more technical transaction-bound components. So the event processors are the technical components. They start a transaction, and within a single transaction, it will invoke all the handlers that are in the same package. That's the default behavior. You can configure that behavior. There's a lot of methods that allow you to change how handlers are assigned to these event processors. That's something we'll have a look at in the next webinar. Just for now, we want to log this and see what happens. So now we have a little bit more information. We can see an account is created. We can see another account is created. We can see the money transfer was requested. We can see the money was withdrawn, it was deposited, and then the transfer was completed. Now let's do the exact same thing in Spring Boot. So we have the same command gateway here, so we can pass the same set of commands to execute, and when I do this, it will fail because we did not do any Spring configuration yet. We have just configured our Sagas to be well, for the plain Java one. So here we see that the account is created, the money transfer was requested, but that's it. So our money transfer is an aggregate, so these command handlers are known, but our Saga is not known to Axon. So we need to tell Spring that the Saga is actually a component that should be part of the application context. And then Axon will detect the Saga in the application context and configure all the wiring for it. Let's see what happens. And now we see the same stuff going on, but the events are not here. That's because we don't tell Spring that this is a component, and this is just a plain Spring component, nothing special, except that it's an event handler. Axon will automatically detect the event handler method on any bean and invoke it when that event happens. So now we have our logging event handler as part of the application context as well. And we should see, we do see now that account was created, money transfer requested, money withdrawn, money deposited, and then money transfer completed. So now for a little scenario where we are overdrawing an account. So let's go for 10,000. Now what we see happening now is money transfer was requested, but we see here that the command withdraw money command resulted in an overdraft limit exceeds exception. But there's nothing in our Saga that deals with that scenario right now. So this command actually fails. There's two things we can do. We can use send and wait, in which case we cannot use a callback anymore, but we are notified of the result immediately. So the Saga will just stick around until the command has been executed. Now we can catch an exception here. The little challenge that we have is that this exception is a checked exception. And we're using a command gateway here, and it wraps checked exceptions in a command execution exception. So we have to do a little ugly stuff. If the overdraft limit, if the cause of the exception is the overdraft limit exception, then we want to, well, we probably want to send a cancel money transfer. So we want to notify the money transfer of the fact that our transfer did not complete. So our transfer ID event.getTransferID failed. But in this scenario, our Saga doesn't end either, so we need to have a Saga event handler to respond to the fact that the money transfer was cancelled. Oops, that was a bit too soon. Public void on money transfer cancelled event. And just for fun, let's do the other approach here. We statically import end just to show the two different ways of ending the Saga. Now if we run this, we can see that our money transfer was cancelled. So money transfer was requested and it was cancelled. We don't see the command here anymore because we don't log, but we could put some logging in here as well. There's another way to do this. So instead of doing send and wait, we can also use send and pass in a command callback. And on success, we don't do anything because we're responding to the event. And But on failure, we want to check the cause. So if well, if it fails, we want to cancel it, but it doesn't really matter why it fails. If the command fails for whatever reason, we want to cancel the money transfer. So this is another way to do it, and it will perform exactly the same way, like so. There's one little thing to take into account. When using a callback, you can't be sure when the callback will be invoked. And in this example, because we use the default configuration, everything is single-threaded. But as soon as we decide to use a different command bus or a different event bus or configure this Saga to be tracking, we have no guarantee when the callback will be invoked. And actually, the callback might be invoked at a time where the method here has already completed, in which case Axon will serialize the Saga and store it somewhere. So if the callback is invoked, never change the state of a Saga here. Always use callbacks just to send new commands or publish another event that can then be picked up by the Saga, for example, to do something. So this is our little process. Of course, if we run it in the Spring version of it, it will perform exactly the same way. But just to show that, we run it. Like so. So we see our money transfer cancelled event popping up here as well. So it doesn't really matter whether you use the Spring, of course, or plain Java. The behavior is exactly the same. So that concludes the coding. So a quick overview of what we've done. We've created these test cases. Of course, we can add test cases for the exception handling as well, but they're very much similar to this. Then there's the Saga. So it has a start Saga on the Saga event handler that needs to create a new Saga. That Saga is then automatically associated with the property of the incoming event. We've seen how we can override the key, or at least the name of the property doesn't have to be the same as the key of the association that we use, etc. There's one last thing that we can do. So instead of using the transfer ID as the transaction ID, we could also generate a new transaction ID. So let's do that for fun. So let's say that our transaction ID, and I don't think it would make sense in a proper environment. We create a random identifier, like so, and we can pass that transaction ID as well. Now, of course, we lose the correlation. Sorry, it needs to be toString. Of course, we lose the correlation between the actual transfer and the withdrawal, but so you don't want to do this in practice. But we are now associated with a different value. So the transaction ID and the transfer ID are now two complete different concepts, because we're using different identifiers for each of them. And that's why we have to be careful here with saying complete money transfer. That's no longer the transaction ID, that is a transfer ID. So we need to store that as well. Event get transfer ID. All right. So in here we have, so the event of the withdrawn and the deposit, they will use the transaction ID. But the complete money transfer uses the transfer ID. Let me call it transfer ID. Like so. But now we need to associate this Saga with the concept of a transaction ID, and that is what we can do. So we can associate it with transaction ID, comma, and then the value of the association is that transaction ID. And now it associates this Saga instance with that specific transaction as well. So when anything happens with that transaction in those method, if the events carry that identifier that we pass in here, then this Saga is invoked, and this will behave should behave in the very same way. Of course, we don't have a money transfer anymore. So we see money transfer requested, money withdrawn, money deposited, so it's successful anyway. So this is how you can associate a single Saga with different concepts in different domains, and this is how you can basically use a Saga to coordinate activity between different domains. So let's have a look at what we have done. We've built the Saga. So for the Sagas, you use @Saga event handler. And that has to do with the association. You want to call a specific instance of a Saga, unlike a general or normal event handler that is just a bean and that listens to all events. We've seen how you can use the command gateway in your Saga instances, how you can inject them, and we have worked with associations. Similar to how you've added associations, you can also remove associations. So when a certain concept is not important for the Saga anymore, you can just remove the association and it will not be triggered by those events anymore. So we've seen how the Saga test fixtures of the aggregates are also, well, they're different fixtures, but they're also there for the Sagas. They have a slightly different API because the Saga has a different type of life cycle. Which you can check in the test fixtures. You can also verify the commands that have been dispatched from that Saga. And then lastly, we have looked at the new Axon 3 configuration API, both in the pure Java sense using the Saga configuration class that we can register as a module with our main configuration, or in Spring, where you can use the @Saga annotation to tell Spring that a specific class defines a Saga. What you can also do is define how you want to store the Saga, so you can store them in JPA. By default, they're stored in memory, which is, especially for Sagas, not recommended in production, so probably you want to use a JPA Saga store. That's relatively easy to configure. There's just a configure method for it on the configuration. And last, of course, you can customize the command bus, and I've already shown a place where you need to be really careful. So in our callbacks, you need to be careful that you don't change the Saga states, because when you customize or at least change the command bus implementation to something asynchronous, there's no guarantee that the callback is invoked when that Saga instance is still alive, even though the callback will have a reference to a Saga instance, but that Saga instance might not be managed by Axon anymore. So that's it for this webinar. I hope you've enjoyed it, and good luck trying everything yourself. So thank you.